Okay, so just like it could help us curve fit, it turns out that these transformations and knowing basic functions can also help us graph. So again, I'm looking for a sketch here. If I wanted more detail, we do some point plotting. But this is just a really quick sketch and gives us a very good idea of what we're expecting to see. And then, like I said, we can always do more details if needed with regard to point plotting. But it all begins by identifying the basic function, identifying the transformations, and then using those to create a sketch. So when I'm looking at this, if you kind of strip everything away, right? Strip away the 1/4, strip away the third, right? The -3, and then strip away that minus x. I don't have enough hands to do that, right? What's left is x squared. So this is basically our nice parabolic function. What's happening to it? Well, since we're subtracting 6 away from the x, this means that we're actually moving right 6 units. Since I'm multiplying, right, again, if you kind of just think of this as 1/4 x squared, what I also have is a vertical compression, right, by a factor of 1/4. So kind of like something we saw in an earlier video, it's just going to be just a little bit flatter. And then this -3 tells us that we're going down 3 units. So essentially I'm going to take my 0, 0, right, this little trio of points here, and they're going to be moved over to the right. 1, 2, 3, 4, 5, 6. They're going to be moving down 1, 2, 3. So there's where that 0, 0 is going to be transferring here. And then without the compression, I'd be going through this point and this point. But with the compression, I'm just a little bit lower. Okay, and so there is a really quick sketch of that graph. If I wanted more detail, I could put, maybe I find the y-intercept. If I wanted a little bit more detail to kind of run on, I think that would be -6 squared minus 3. So I get 36 over 4 minus 3, 9 minus 3, that's 6. So this is going through 0, 6. So there's a little bit more detail about what that graph is doing, if needed. But we generally had the right idea. And of course, you can turn your graphing calculators to see that you're right. I'm not going to do that here. The next graph, again, if we take away the -3, and if we take away that +2, I think we see the basic function, the reciprocal function, 1 over x. Again, under normal circumstances, right, it's going through 1, 1, -1, -1. The x-axis is serving as a vertical asymptote, and the y-axis is serving as a horizontal asymptote, and we got those nice curves there. Okay, so there's the basic function, what it's doing, right? So this and this. So what's happening here? Well, since I'm adding 2 to the x, that tells us that we're moving to the left twice. Right? If you took the +2 there, I'm subtracting 3 from the 1 over x. So that means we're moving down 3. So, and I don't see any multiplications going on, so there's no vertical compressions or vertical stretches. So that's basically it. So we're going to move to the left 2, and we're going to move down 3, which means that all this action here, right, let me kind of draw it in here. All that action is going to shift there. So it's almost like we're taking our origin and shifting it down 3 into the left 2. It's going to be going through that point. It's going to be going through that point, right? Because that point moves down 3 and over 2. This old point moves down 3 and over 2. So what's the graph look like? It roughly looks like this. All right, and so there's our sketch of 1 over x plus 2 minus 3 by using my transformations and my knowledge of basic functions. So again, very, very important, right? Knowing those basic functions and their shapes. Last but not least, if we strip everything away, what's left is the absolute value of x. So this graph again goes through 0, 0, 1, 1, and -1, 1, but it's looking very linear. So there's kind of an essential shape of it. What's happening? Well, it looks like we're subtracting 1 from the x. So that means we're moving to the right 1, right? The +3 means that we're moving up 3. This is loaded, right? We're multiplying by 2, so I'm expecting it to be vertically stretched, so it's going to be a little skinnier by a factor of 2. And then the fact that it's negative means that we're basically going to be reflecting through the x-axis. So rather than pointing upwards like it normally does, it's going to be pointing downwards. So it's going to be pointing downwards and a little skinny. That's what these two things say. So this point 0, 0 is going to be shifted over to the right one, and it's going to be shifted up 1, 2, 3. So it's going to be here, and then it's going to just be skinnier. So there's a really quick take on what I think the graph's going to look like. Again, if you want a little bit more detail, plot a point. Again, maybe we try the y-intercept. When I put a -2 in there, we get -1 squared, and that's basically going to be a -2 plus 3. I get 1. So I'm a little off there. So there's a little bit more detail. All right, so I guess I was a little off, but there's a little more detail in that next graph. But again, I just wanted a quick sketch. I did show it, getting a little skinnier. So that's how, using a basic function and using a kind of stripping away all the transformations around, we can get a feel for what's happening and draw a really quick sketch. When you get really good at this, you can even be faster than these guys. That's all, it takes practice. So we'll see. So that wraps up this idea. All right, obviously, again, we're about halfway through, so much more to do with basic functions and transformations. See you guys in some videos soon.